Hello George. Welcome to this video about globe-type control valve parts. Control valves are an essential component of many industrial processes, regulating the flow of fluids to maintain precise control of temperature, pressure, and other critical parameters. In this video, we'll take a closer look at the main parts of a globe-type control valve, their functions, and the different types available. By the end of this video, you'll have a better understanding of how control valves work and are better equipped to choose the suitable valve parts for your specific application. So let's dive in. Globe-type control valves are called globe-type because of the shape of their valve body, which looks like a globe or a sphere. A globe-type control valve is a type of valve used to regulate the flow of fluids in industrial processes. It consists of a valve body with an internal passageway, a valve plug that fits inside the passageway, and a valve seat that forms a seal with the plug. The plug is connected to a stem that moves up and down, controlling the flow of fluid through the valve. Globe-type control valves are commonly used in applications where precise control of flow rate, pressure, or temperature is required, such as in the chemical, petrochemical, and power industries. They are available in a wide range of sizes and materials to suit different process conditions. In this figure, we can see a globe-type control valve, including an actuator and valve body, two parts. Let's take a closer to each of the parts. Valve body. The valve body is the main component of the valve that houses the other parts. It is typically made of cast or forged steel and contains an internal passageway through which the fluid flows. The valve body is divided into two halves with a central port that connects the inlet and outlet pipes. Valve plug. The valve plug is a plug-shaped component that fits inside the valve body and controls the flow of fluid. It is connected to the stem by a yoke and moves up and down to adjust the flow rate through the valve. Valve seat. The valve seat is a ring-shaped component that forms a seal with the valve plug when the valve is in the closed position. It is typically made of a soft material or metal material, in order to prevent leakage to the valve seat and ensure a tight seal. Stem. The stem is a long, slender component that connects the valve plug to the actuator. It moves up and down to adjust the position of the valve plug and control the flow rate through the valve. Bonnet. The bonnet is the cover that seals the top of the valve body and houses the stem. It is typically bolted or threaded onto the valve body to provide easy access for maintenance and repairs. Actuator. The actuator is the component that provides the force needed to move the stem and control the position of the valve plug. It can be operated manually, electrically, pneumatically, or hydraulically, depending on the application. Packing. The packing is a set of rings or sleeves that surround the stem and prevent leakage of fluid around the stem. It is typically made of a soft material, such as graphite or PTFE, and is compressed against the stem by the bond. Bellows. The bellows is a flexible component that connects the stem to the actuator and prevents leakage of fluid or gas through the stem. It is typically made of a metal alloy or other flexible material and can withstand high pressures and temperatures. Bellows are often used in applications where a tight seal is required, such as in the chemical or nuclear industries. Each of these components plays a crucial role in the function of a globe-type control valve, and their design and material selection can affect the valve's performance in different applications. Here are three common types of globe control valve bodies: single-port globe control valve, double-port globe control valve, and three-way globe control valve. Next, we will explain the different designs and specials of different types of globe control valves, as well as their advantages and disadvantages. Single-port globe valve body. This type of valve body has a single port or passageway through which the fluid flows. The advantages and disadvantages of this type of valve body are: advantages: easy to manufacture and maintain, simple design with fewer parts, tight sealing, low cost compared to other types of valve bodies. Disadvantages: limited flow capacity, higher pressure drop compared to other types of valve bodies, limited use in applications requiring high flow rates or high pressure differentials. Double-port globe valve body. This type of valve body has two ports or passageways through which the fluid flows. The advantages and disadvantages of this type of valve body are: advantages: larger flow capacity compared to single-port valve bodies, lower pressure drop compared to single-port valve bodies, can be used in applications requiring higher flow rates or pressure differentials. Disadvantages: more complex design with additional parts, more difficult to maintain, large leakage ANSI 2, Toman 3, higher cost compared to single-port valve bodies. Three-way globe valve body. This type of valve body has 3 ports or passageways and is used for diverting or mixing fluids. The advantages and disadvantages of this type of valve body are: advantages: allows for mixing or diverting fluids in a single valve, more versatile than other types of valve bodies. Disadvantages: more complex design with additional parts, more difficult to manufacture and maintain, higher cost compared to single-port or double-port valve bodies. Overall, the choice of valve body type depends on the specific application requirements, such as flow rate, pressure drop, and fluid type. Each type of valve body has its own advantages and disadvantages, and it's important to consider these factors when selecting the appropriate valve body for a particular application. During harsh conditions, we apparent will face cavitation, flashing, or erosion problems for control valves. A liquid generates cavitation or flash damage for control valves, often caused by upstream pressure and differential pressure. A high differential pressure affects the high velocity of flow like steam or entrained solids, which cause the potential for erosion. And the corrosion caused by the passive layer of steel is washed away from the high velocity. This figure is a testimony to the continuous innovation of think tank technology and the continuous upgrading of control valve trim design for harsh working conditions. In this video, we've explored the main parts of a globe-type control valve and the different types of valve bodies available. The valve body, valve trim, stem, bonnet, actuator, packing, and bellows all play a crucial role in the performance of a control valve. Meanwhile, the type of valve body used can affect the valve's flow capacity, pressure drop, and cost. Single-port, double-port, and three-way valve bodies all have their advantages and disadvantages, depending on the specific application requirements. Choosing the right parts and body type for a globe-type control valve can be a complex process, but it's crucial for achieving precise control of fluid flow, pressure, and temperature in industrial processes. By understanding the function of each component and the differences between valve body types, you'll be better equipped to select the appropriate valve for your specific application. We hope this video has been informative and helpful in increasing your understanding of globe-type control valve parts. If you have any questions or comments, please feel free to leave them below. Thank you for watching.